In these 3-phosphoglycerates, what again is happening is another enzyme known as phosphoglycerate mutase. So anytime you hear the word mutase, we are what? Either adding water or we are either removing water. So mutase means we are removing or we are adding water. So the process by which we are adding water, we call it what? Hydration. The process by which what? We are removing water, we call it dehydration. So we are dehydrating 3-phosphoglycerates by an enzyme known as phosphoglycerate mutase towards 2-phosphoglycerates. To 2-phosphoglycerates. 3-phosphoglycerates is converted towards 2-phosphoglycerates. Now, this 3-phosphoglycerates was just 3 molecules and 1 phosphate group is now attached on it. So when we convert it to 2-phosphoglycerates, this 3 molecule, this phosphate group will now come here and attach. That is what we mean by 2-phosphoglycerates. Now from 2-phosphoglycerates, another enzyme called enolase. Repeat after me, enolase. Another enzyme called enolase now converts 2-phosphoglycerates to phosphoenolpyruvate. I call this PEP. PEP. So the 2-phosphoglycerate is converted to what? Phosphoenolpyruvate by taking ADP molecule and converting them to what? ATP. When we take ADP molecule, we now convert them to ATP. So during this process, we now convert this phosphoenolpyruvate to what? Pyruvate. And what is doing that? Kinase. Anytime you see we are converting ADP to ATP or from ATP to ADP, just first thing that should just click into your mind is that kinase is involved. There is ADP, there is ATP. What else now follows? Kinase. Don't forget this. Anytime ADP, ATP, so that you use this to remember all these pathways. Anytime ADP to ATP or from ATP to ADP, kinase is involved. And which kinase is involved in converting phosphoenolpyruvate to pyruvate is now called what? Pyruvate kinase. And this is what we call glycolysis. And how many pyruvate have we produced? So in every 1 glucose molecule, we produce what? 2 pyruvate. So what is pyruvate? So what is glycolysis? Therefore, glycolysis can be said to be defined as the process by which we convert glucose, which is 6 carbon atom, to 2 molecules of pyruvate, which are 3 carbon atom. Don't forget that. So let us just do a summary of this glycolysis. So glycolysis is conversion of glucose to pyruvate. Now from pyruvate you now convert to glucose 6-phosphate by hexokinase or glucokinase. From glucose 6-phosphate to phosphohexoisomerase, and from hexoisomerase you now convert it to fructose 6-phosphate by phosphofructose kinase type 1, which is ATP is converting it to ADP. Now from this we now convert it to fructose 1,6-bisphosphate. From fructose 1,6-bisphosphate by an enzyme called aldolase now act on it to convert it to dehydrogen acetone phosphate and glyceraldehyde 3-phosphate. So we cannot proceed with this reaction to pyruvate. So it's only glyceraldehyde 3-phosphate that our body can convert to pyruvate. So what our body do is to convert this dehydrogen acetone phosphate to glyceraldehyde 3-phosphate, making it 2 molecules of glyceraldehyde 3-phosphate by an enzyme known as triose phosphate isomerase. From there we now convert glyceraldehyde 3-phosphate to 1,3-bisphosphoglycerate, and this enzyme is done by what? Glyceraldehyde 3-phosphate dehydrogenase. And from there we now convert bisphosphoglycerate to what? 3-phosphoglycerate by an enzyme known as phosphoglycerate kinase by taking ADP to ATP. From there we now convert 3-phosphoglycerate to 2-phosphoglycerate, and it's done by an enzyme known as phosphoglycerate mutase. From there we now convert 2-phosphoglycerate to enolase to phosphoenolpyruvate, and which is done by an enzyme enolase converts 2-phosphoglycerate to 2-phosphoenolpyruvate or to phosphoenolpyruvate, and it is done by enolase. From there we now convert phosphoenolpyruvate to pyruvate by an enzyme known as pyruvate kinase. So this is all I have for you. Don't forget to like, subscribe, and jot down all these things for later consumption. So what are the outputs of this reaction? Is we use 1 glucose to produce 2 pyruvate and 2 ATP net. Remember that we added 2 ATP molecule and we produced 4 ATP molecules. 4 ATP molecules. So what is the net ATP that we have? So 4 ATP minus 2 ATP, we now have what? 2 ATP molecules. Now, what else? We added ADP. We added 2 molecules of ADP and we produced 4 molecules of ATP and 2 molecules of NADH, which is now going to the mitochondria to produce much energy. So we now convert NAD positive to NADH, 2 and 2 pyruvate. So the total of what we are producing, we are producing what? What is our net yield? Our net yield is we are producing 2 ATP, 2 NADH and 2 pyruvates. Don't forget that. Don't forget to like, subscribe and hit the notification bell for more videos like this. So take this equation home. We are converting glucose. We take glucose plus 2 NAD positive plus 2 ADP plus 2 pyrophosphates. We now convert them to what? Pyruvate plus 2 NADH plus 2 hydrogen ion plus 2 ATP and plus what? 2 water molecule. Don't forget to like, subscribe and hit the notification bell for more videos like this on Sagacious Learners. See you next time.